Good evening, friends. Welcome to 360DigiTMG. Today, we are going to understand about generative AI model, which is multimodal. Okay, so let's get started. So, here in generative AI, what is generative AI? So, generative AI refers to a set of artificial intelligence methodologies that can produce new content like text, code, images, videos, audios, and so on and so forth. So that resembles the training data on which they were trained. For example, this is our input text. Okay, and what we want to summarize that text. So for that, we will use a Gen AI model. Okay, and after that, this whole text will be generated into a summarized format. Okay, for this purpose we can use this. Okay, likewise, what are modalities? So in generative AI, modalities refers to different kinds of data that the model can handle and create. This includes text, images, audios, videos, and other type. When it comes to modalities, there are two main types of generative AI models. First is a single modality models and second is a multi-modality models. So in single modality models, what happens? They generally focus on generating one content at a time. For example, if our input is in text format, so it will give an output in text format itself. Or for example, our input is in image format, it will give an output in image format, and so on and so forth. Likewise, in multimodality models, they can handle and generate various types of content such as text, images, audios, all together can generate text images or um, images to text and other things also. So this is our single modality models, which generally focuses on only one content at a time, and multimodality models, which generates various types of contents. Okay, so in multimodal generative AI models, we are looking at three key components. So first is our input section. This part includes neural networks, which is capable of handling different types of data simultaneously. Okay, then there is fusion segment. So here in fusion segment, what happens? Here, the information from various modalities is blended and understood together. Okay. And in output model, this section will produce the ultimate result in one or more types of data formats. So these are our input, which is in text format, images, audios, videos, and more. Okay. So what we'll do, it will take it and it will store it in an encoder format. And then it will use our Gen AI model to generate the output of it, which can be in text to text also, text to images also, text to audio also, text to videos also. Likewise. Okay. Then there is, for doing this, there are various large language models. So first is our Lava, which is our large language and vision assistant. So Lava is a combination of Vicuna, that is LLM, and which is also one of the model, and vision encoders to enable visual and language comprehension. Okay, with a focus on visual instruction tuning, Lava has been engineered to rival the capabilities of GPT-4V. Okay, so what it will do, it will demonstrate its exceptional prowess in understanding both the languages also and the vision also. Okay, so this state of art models will excel in the task ranging from impressive chatbots interactions to setting a new standards in science question answering accuracy, which is having an accuracy which is 92.53%. Okay. With Lava's innovative approach to instruct following data and the effective combinations of vision and language models, it promises a versatile solutions for diverse applications, like marking a significant milestones in the field of multimodal AI. Okay, so this is about Lava. Then there is GPT-4 Vision. GPT-4 Vision is a multimodal model that allows a user to upload an image as an input and engage in engage in a conversation with the model. The conversation could comprise questions or instructions in the form of prompts, directing the model to perform tasks based on the inputs provided in the form of an image. The GPT-4V model is built upon existing capabilities of GPT-4, which offers the visual analysis in addition to that of interaction features. Okay, what are the whatever the earlier existing features, now it is an add-on or addition to that. Okay, suppose this is our image, and what we are doing, this image, we are converting this image into a vision encoder. After that, we are using the receiver resampler. In this receiver resampler, after that the image is then freeze or trained from a scratch during a flamingo training. Okay, after that, whatever will be the uh, receiver resampling has been done, it will be formatted to our whatever the vector database there is. Okay, and after that there will be an output generated. Okay, and see here, we can see that this is a very cute dog. This is an image to text transformation. Okay, likewise this is for cat. Okay, for captioning also we can use this. Then the examples of Lava versus GPT-4 Vision. So here this is our text, this is our image. Okay, and what they are and here after in uploading the image, what we are saying what's an unusual about this image, and we are comparing the difference whatever the output has been shown with respect to GPT-4 Vision and Lava 1.634 billion model. Okay, and see, these are the two outputs which has been generated from GPT-4 and Lava. Okay, after that there is Few 8B. Few 8B is a decoder only. Here there is no encoder. It is only having decoder. It is a multimodal model based on classic transformers architecture with a query and key normalization. A linear encoder is added to create multimodal embeddings from image inputs. Okay. Then see, here is an example of Fuyo 8 billion. So this is of an image, and what we can see the caption with respect to this, and it is showing the caption what has been written in this cake or what has been written in this image. Okay. Then this is in stock market report. Okay, and this was the question: what is the highest life expectancy at birth of males? And the FUU's answer is the life expectancy at birth of males in 2018 is 80.7. So here it is giving quite good outputs. Then there is Brevial, which is Bridging Visions and Language Multimodal Models. Brevial is in two tower pre-training models within the cross-model constructive learning framework. A cross-model pre-training model is defined based on the image text retrieval task. The main goal is thus to learn two encoders that can embed image and text, that can embed image also and text also as in samples into the same space for the effective image text retrievals. To enforce this cross-modal embedding learning, this is called as cross-modal embedding learning. Okay, to enforce this learning, we introduce constructive learning with the info NCE loss into the prevail model. Given text embeddings, the learning objective aims to find the best image embeddings from the batch of image embeddings. Similarly, for a given image embeddings, the learning objective is to find the best text embeddings from the batch of text embeddings. The pre-training model learns a cross-model embedding space by jointly training the image and text encoders to maximize the cosine similarities of image also and text also. Okay, of the true pair for each samples in the batch while minimizing the cosine similarities of both embeddings, okay, which is an incorrect pairs. So it will take this image, this image, this image, this image, and this two image and these two text, okay, and it will detect what will be suited for this caption and what will be suited for this image caption, and then it will generate our output with respect to this. Okay, then there is comparison and examples of preview. So this is our vision also. Here what we are doing, we are feeding the vision like image also, and we are feeding the text also. And after feeding the image and text both simultaneously, we are taking the image encoders and we are taking the text encoders, and we are doing the constructive learning in between these two. And whatever will be having a cosine similarity more, that will be text, that will be given the caption to image text retrieval. And if we want that can be used for text to image generation also, this can be useful for visual question answering also. So this can be the outputs. For this we can use brief VL. Okay, then there is Salmon. Okay, this is a speech audio language music open neural network. Salmon is a speech audio, as we can see by its name. Salmon is a speech audio language music open neural network. It is built by integrating a pre-trained text-based LLM with speech and audio encoders into a single multimodal models. Salmon enables the LLM to directly process and understand general audio inputs, achieving competitive performance on the numbers of speech and audio tasks used in the training. These tasks can include automatic speech recognition, it can be used for translation, it can be used for auditory information based question answering, emotion recognition, it can be used for speaker verification, it can be used for music and audio captioning, and so on and so forth. The Salmon framework also deploys a Vicona LLM, which is a Llama large language model framework, fine tuned to follow the instructions more accurately and effectively. The LoRa framework is a common method used for parameter efficient fine tuning, and it's induced the weight matrix and adapts the. Okay, then there is QuenVL. QuenVL is a Quen large vision language model. Okay, so QuenVL series comprises a set of large scale vision language models, which is designed to perceive and understand both the text also and images also, as that of what we have seen previously, pre-VL, same as that of this. Starting with Quinn LM as a foundation models, we will enhance its capability with visual perceptions through meticulously designed components, which includes visual receptors, input-output interfaces, three-stage training pipelines, and multilingual, multimodal cleaned corpus. In addition to that, there will be a convolution task such as image description, question answering, which can be implement the text reading abilities of Quen VLs by aligning the image caption box tuples. These resulting models will then include the Quen VL and Quen VL chat both and sets a new records for journalist model of similar scales across broad range of mutual centric benchmarks. For example, like we have seen in image captioning, question answering, mutual grounding, and various settings like zero shot prompting, few shot prompting. This can be achieved with respect to QuenVL. Okay, it can be used for, like, as we have seen here. First, we are using this pre-training models. We are using the Quen LM, and we are using this for image text pairs. Then after that, we are using Quell LM, and we are using the cross attention mechanism, and we are using this multitask. Okay, multitask, and it can be used for interleaved VL data. Then for Quen LM, we are using this cross attentions, and we are using this for chat interweight VL data. Okay, so by giving the zero shot, few shot prompting, we can achieve this. So then there is multimodal data sets which are available. Okay, so these are publicly available data sets. Some of the data sets which are publicly available, which is the COCO data set, which stands for Common Objects in Context. This is an image data sets which was created with the goal of advancing the image recognition. The COCO dataset contains challenging, high quality visual datasets for computer vision, which is mostly state of art neural networks. Then there is conceptual captions. This conceptual captions is, it is a data set which contains image URL. Okay, it might have captions as well. It pairs designs for training and evaluations of machine learned image captioning systems. Okay, then there is Fleek R30K, which is one of the popular benchmarks for sentence based pictures, or what we can say sentence based portrayal. This data set has over 31,000 images. Each image in the data set has 5 reference sentences provided by the human annotator. The annotations on each image allows for progress in automatic image descriptions and grounded language understanding. Then there is public multimodal datasets, which is PMD. It is a collection of publicly available image text pairs dataset, which was introduced in a flavor paper. Okay, this is one of the paper. Okay, then this is public multimodal datasets, which is PMD, contains 70 million image text pairs in total, with 60 million unique images, 68 million. The dataset contains pairs from conceptual captions for 12 millions. Then there is with localized narratives, red caps, COCO, SPU. Then there is visual genomes and subsets of this data sets, YFCC 100 million data sets. This is also one of the data set. Then there is data sets for cross modal benchmarks. Now, the cross modal benchmarks, like we have seen from like from text to image, image to text. Like for that, there are different cross modals benchmarks are there. So first is our VQAV2. VQAV2 is an advanced data set in AI for developing and testing models that combine visual and textual understanding. Okay. It contains open-ended questions about images. These questions will require an understanding of vision language and common sense to answer. Okay. This is the second versions of VQA datasets. First was a VQA dataset, and after that there was a second version to VQA dataset, which is VQA V2. Then there is OKVQ. OKVQ is a visual question answering benchmarks, which requires external knowledge, which addresses the task of knowledge based visual question answering, and which provides a benchmark where the image content is not sufficient to answer the questions. Okay, where the image content is not sufficient to answer the questions. Okay, then there is encouraging methods like that relies on the external knowledge resources. Okay, so this data set will include more than 14,000 questions that requires external knowledge to answer. Okay, then there is text VQA, a data set to benchmark visual reasoning based on text and images. It requires model to read and reason about the text and images, right? So here what will happen? Here the model will understand it, the reason from the text when it converting it to images. Okay, to answer the questions about them. Specifically, models need to incorporate a new modality of text present in the images and reasons over it to answer the text VQA questions. Like there will be one image and the model will learn from that image and then it will answer the questions based on that. Then there is STVQA. STVQA is a data set which is a data set to benchmark based on high level semantic information which presents in the images as textual clues. It can be in the form of it can be in VQA process. Okay, this data set defines a series of tasks of increasing difficulties for which the scene text in the context which is provided by the visual information will become necessary to reason and generate an appropriate answer to that image or that text. What we can say, scene text is there. Okay, in this scene text there will be some context over there, and by looking at that context, by looking at that visual information what is present, we need to reason and generate answers to that. Okay, so this is it from cross model benchmarks. Okay, let's have quick revision of what we have seen today. So first we have understood about the generative AI. Okay, it what generative AI is? Generative AI is a set of artificial intelligence which creates new content. Like it can create codes, images, text, audios, videos, and so on and so forth with respect to that of pre-trained models. Okay, there is some pre-trained model with respect to that it will generate. Okay, now we'll see then we have understood about what is modalities. What is modalities? So modalities is when we have a different kind of data the models can handle. Like there are two kinds of modality. First is single modality models and multi-modality models. Single modality model will contain one type of information at a time, and multi-modality models will generate various types of content at the same time. Suppose we want to uh, from text to images we can have it. From image to text we can have it like that. Then we have understood about the multimodal generative AI models, and we have seen its three key components like input sections, fusion segments, and we have understood about the output modules. Okay, then there is these are all the models. Okay, so first we have seen lava models, which is a large language vision assistant, which we have seen. Okay, then we have seen GPT-4 vision. Okay, GPT-4 vision we have seen. This model is built upon existing capabilities of GPT-4 only, which offers visual analysis in addition to that of GPT-4. Okay, then we have seen the differences between what lava model as well as GPT-4 model. Okay, GPT-4 vision. Then uh, we have seen there is one image, and we have written one question like what is unusual about these two images, and whatever the output has been generated from the GPT-4 and whatever the output is generated from the lava model. Okay, so this was the difference between, you can see the difference between these two. Then we have understood about the PUAD model, which is also a this is a decoder only model. It doesn't have encoder itself. So it is a multimodal model which is based on classic transformer architecture, which creates multimodal embeddings from image inputs. See, this is a image input, this is our input, and it will create some output in the form of text. Okay, by considering some image patches one by one. Then this is also one of the example. This is a cake, and what is written in this cake, that is as a caption has been shown. This is also one of the question asked by giving the image, and we can see the question answering also, it is giving good results. Then this is brevial. Brevial we have seen, this is also a bridging vision and language multimodal model, which is a two tower pre-training models. Okay, which what we'll do, we will feed the image also and we will feed the text also in it, and we will take the encoders of all these things, and then we will match these things, and then we will feed our output with respect to previal. Okay, see here, we are giving two inputs, we are taking the outputs from this two, and we are taking the constructive learning, and then we can use this constructive learning of these image and text to form, like it can be used for visual question answering, it can be used for different purposes. Then there is Salmon, that is a speech audio language music open neural network that we have seen. Okay, then we have seen Quen VL model. Okay, so this also we have seen in the pre-training process and multitask pre-training, and then by using a supervised fine tuning. Then we have understood about the multimodal data sets. So we have understood about the COCO data sets. We have understood about what COCO data set does. It has a high quality visual data sets for computer vision task, and it can be used for YOLO models. It is used for YOLO model conceptual captions. Okay, this data set is useful for image URLs or giving captions and other things also. Then Flickr 30K, this is also one of the popular benchmark data set, which is having 31,000 images in it, and each image has the data sets have 5 reference sentences provided by the human annotators. Okay, then there is public multimodal data sets, that is PMD, which is trained on 70 million image text pairs, out of which 68 millions is a unique images. Okay, then we have understood about the cross modal benchmarks. We have understood about VQAV2, which is an advanced data set which is used in AI for developing and testing the models. Okay, then we have understood about the OKVQ benchmarks, which is a visual question answering benchmarks, which is this is data sets includes more than 14,000 questions. Okay, then there is text PQA. This data set is a benchmark which is used for text and images, like if we want to, if there is one image, and what we will identify what is there in this image, and then we can use it for question answering task and other things also. Then there is SGVQA. This SGVQA data set is also a it is also a high level semantic information data set. Okay, so this data set defines a series of tasks for increasing the difficulties for which the reading the scene text. Okay, like what is present in the text there, they will check, and then they will visualize it the information, and then we can have a appropriate answer with respect to the context. Okay, then we have understood about chart QA, we have understood about info VQA, we have understood about doc VQA, wit, prop evil. So this is it for today. See you in next lecture. Thank you for joining. Bye bye.